Alright guys, welcome back to li.edu, and today we are going to be zooming into the incredible unseen world of microbiology. Now, from its humble beginning to its monumental impact on nearly every aspect of our lives, prepare to be amazed by the tiny living creations that shape our very existence. Now, it all started with Antonie van Leeuwenhoek, the pioneer who first see into this hidden realm of microorganisms, revealing the universe of animalcules. Now, we've discussed that in our previous class. Now, but for a long time, studying these microscopic beings was incredibly very difficult. How do you cultivate something you can't even see properly? Because as at this time, the knowledge of microorganisms was still at its early stage. Now, the cultivation technique was propounded by Robert Koch, a true visionary. He revolutionized microbiology by developing a way to grow and isolate these tiny organisms. Now, how did he do this? He used sliced potatoes, meat extract, and gelatin. He tirelessly experimented with culture mediums. Now, through gelatin, though it has flaws because it melted easily and it was often eaten by microbes themselves. So despite using this, there were challenges with his experiment. Then he came with a brilliant suggestion from an unexpected source, which was Fanny Essay. Now, Fanny Essay was the wife of one of Koch's associates, and her idea was agar. Now, agar is a seafood derived from a substance that is called algae, and now this became a game changer because most bacteria will not be able to digest it, and it stays solid even at warmer temperatures up to 52 degrees Celsius. So thanks to this breakthrough, Koch and his team was able to develop the fundamental tools we use today, like the nutrient agar and broth. And also Koch associate Richard Petrie was able to invent the famous Petri dish we use today in our laboratory in the year 1887. The discovery of viruses. Now, Dmitry Ivanovsky and Marcellus Bedring studied the tobacco mosaic disease using the Charles Chabannet bacteriological filter. Now, in their experiment, they filtered extract from diseased plants, and surprisingly, the filtrate, which should have been free of bacteria, still infected early plants, and this led to the groundbreaking and discovery of the virus. Now, this virus conclusively was causing disease or existed in smaller size, far smaller than a bacterium, and though it was misunderstood at that time, but it was an infiltrable agent, so they named it infiltrable agent and was eventually named the virus. Now, early discovery of immunization. Now, thanks to Liz Patron working with the chicken cholera, he made an accidental yet a great discovery by weakening microorganisms through heating and incubation. Now, these weakened organisms lost their ability to cause diseases, though these weakened organisms were still able to trigger an immune response. So when these attenuated, which is weakened organisms, microbes, were given to healthy chickens, the healthy chickens became resistant to future infections. Therefore, Patrick called these weakened organisms vaccines. So that is how vaccines were discovered. Now, a tribute to Edward Jenner's pioneer work with cowpox, protecting against this smallpox. Jenner's observation of milk maize immunity laid the foundation for the modern immunization we have today. Beyond life organisms, Emil von Behring and Sebastian Hitasato also showed how inactivated toxins could provide protections. Now, Pascal's brilliance led to vaccines for anthrax, fowl, cholera, and rabies. His incredible achievements, especially the rabies vaccine, were so impactful that even the French government built the prestigious Pasteur Institute in Paris in his honor in the year 1882. Don't forget, this is the evolution of microbiology, and here we are today, the present day microbiology. Don't forget to click the like button and follow for more. Bye.